Welcome to our next class of the basic concepts, and the topic for the today is polyatomic ions or radicals. And at the same time, the second topic that we will discuss is the molecular ions. These are the two topics of our discussion for today. One is the polyatomic ion or radicals, and the second one are the molecular ions. Now, what is a polyatomic ion? It can be defined as the electrically charged group of atoms the electrically charged group of atoms that are called as the polyatomic ions, or they are called as the radicals. For example, polyatomic ions may have positive or negative charge. Carbonate, bicarbonate, sulfate, phosphate, etc. These are the examples of the negative polyatomic ions. There are so many other examples of the negative polyatomic ions, like acetate is also an example. As far as the positive polyatomic ions are concerned, there are two famous inorganic positive polyatomic ions: ammonium ion and hydronium ion. One is the ammonium ion, second is the hydronium ion. This one is carbonate, bicarbonate, sulfate, phosphate. You can see that a common suffix ate is used in every name: carbonate, bicarbonate, sulfate, phosphate. And similarly, in case of positive ion, IUM is used. And this IUM is basically an indication of the positive ion. Carbonium ion, oxonium ion. So IUM, it is an indication of the positive ion. Now there is one thing to note, and that is, when I have quoted the examples of the negative polyatomic ions, I have quoted 4 examples, and I have quoted these 4 examples because they are very common. Otherwise, there is a huge list: cyanidine, Cn minus. There is a huge list of the polyatomic ions or radicals. But when we talk about the positive polyatomic ions, there are only 2 famous examples. So there is a important note here that anionic polyatomic ions are more abundant than cationic polyatomic ions. Means those polyatomic ions that carry the negative charge, they are much more abundant as compared to those polyatomic ions that carry the positive charge. What is the reason behind it? If you are studying it for the first time, when you are studying the polyatomic ions for the first time and you are a student of the first year, then you must not stuff your mind with it. You must just keep in mind that anionic polyatomic ions are more abundant as compared to the cationic polyatomic ions. But if you are a student of second year or you are a student of entry test, then you can easily understand it. Why these negative ions are more abundant? Because of resonance they are more stable. Now, if you are a student of the first year, you may confuse with the resonance, so don't stuff your mind. Wait for the right time. Like, I'm writing it here, like this one is the carbonate ion. Now, it has three resonance structures. And the third resonance structure you can see that it is having the three resonance structure. Mean this negative charge is moving on oxygen atoms. Here is the double bond, these two oxygens are negative. Then here is the double bond, these two oxygens are negative. Then here is the double bond and these two oxygens are negative. When the negative charge moves on different atoms, these are called as the resonance structures or canonical forms. And you know the greater resonance structure result in greater stability, so they are more stable. But in this case there is no resonance, so they are less stable. And the thing that I have found that why these polyatomic ions are more abundant, that is their stability due to resonance. So they are stable, they are more abundant. In case of cationic polyatomic ion, there is no resonance, they are less stable, so they are less in number. Similarly, as far as the sulfate is concerned, if we consider this one is the sulfate, there will be resonance. How there will be resonance? Mean this negative charge will move like this. So these are different resonance forms of the sulfate ion, SO4 minus 2. So due to resonance, greater the number of resonance structure, more will be the stability. So due to resonance, these negative polyatomic ions are more abundant. But this concept is again only for those students that have some idea of the resonance. If you do not have idea of the resonance, then do not stuff your mind with it. Now let us discuss the second category. These are the molecular ions. Now what are the molecular ions? If a molecule loses or gains an electron and becomes positive or negative, respectively, then it is called as molecular ion. So it is actually the molecule which were once neutral, but now it has lost an electron or it has gained an electron. So if it loses an electron, it will get positive. If it gains an electron, it will get negative. And when it will become positive or it will become negative, it will be called as the molecular ion. For example, CH4 positive, CO positive, N2 positive, etc. Formation how the molecular ions are formed. So when we take a substance in gaseous form and we pass either a high energy beam of electron or alpha particles or X-rays. These high energy beam of electron, alpha particles or X-rays, they strike with the electrons of molecule and one electron or two electrons they are knocked out. Mostly one electron is knocked out. So the unipositive molecular ions are created. Before hitting the electrons, these molecules were neutral, but when alpha particle, X-rays or high energy beam of electron hit the electrons, they knock them out. So when the electrons are knocked out, now the neutral molecule gets the positive charge and it becomes a positive molecular ion. You will be thinking why I have not quoted examples of the negative molecular ion. Just because the negative molecular ions are very rare. So in this case, the one thing which is to be noted is that reverse that case, cationic molecular ions are more abundant than anionic molecular ions. So cationic molecular ions are more abundant as compared to the anionic molecular ions. And even the cationic molecular ions are easy to be created as compared to the anionic molecular ions. Now what is the importance of these molecular ions? Let me remind you one thing, that these molecular ions are also formed in the ionization chamber of the mass spectrometry. So if a substance is broken into its molecular ions, then with the analysis of those molecular ions, as there was a substance, we broke it into its molecular ions with the help of heat, with the help of radiations. When this substance is broken into its molecular ion, now this technique is used for the analysis of this substance, and much important information about the structure of this substance can be obtained when we break this substance into molecular ion. How this information is gained, we will discuss it in some other lecture. Now these are the polyatomic ions and the molecular ions. Question can be asked that define them and give examples. These are important point for MCQs, that here the anionic polyatomic ions are more abundant, here the cationic molecular ions are more abundant. So these are very important for the MCQs. Let me discuss one or two MCQs with you people. Which of the following radiation is not used to create the molecular ions? Which of the following is not used? So you know, beam of electrons are the ionizing in nature. X-rays are ionizing radiations. Alpha particles can ionize the gases. But gamma rays are non-ionizing radiations. So they are not used to create the molecular ion. Similarly, neutrons are also non-ionizing. So neutrons can not be used for the ionization of the molecules. Mean gamma rays and neutrons cannot be used to create the molecular ions. After that, let's discuss another MCQ. CH3 COO negative O2 positive CH3 positive Cn negative. Which of the following is a molecular ion? Which of the following is a molecular ion? This is an area where the students are often confused how to check which one of the following is the polyatomic ion or radical and which one of the following is the molecular ion. Let me tell you a very simple story. If you want to decide that which one of the following is the molecular ion, remove the charge. For just an instance, remove the charge. When you remove this charge, now see that which of the following is a molecule. After removing the charge, now you are to decide that which of the following is a molecule. CH3COO. We have studied that CH3COOH is acetic acid. It is in molecular form, but CH3COO is not any molecule and it cannot exist independently. CH3, no. Methyl is a radical, alkyl group. It is unstable because carbon makes 4 bonds and here the carbon has made only 3 bonds. So it is not a molecule, it cannot exist independently. CN, in CN, again the carbon and nitrogen have made 3 bonds, negative charges on carbon. Carbon forms 4 bonds, so it is again not a molecule. Now, which of these is a molecule? I think oxygen is a molecule. O2 can exist independently. So this one is a molecule. And when the molecule will have charge, that will be called as the molecular ion. So CH3COO negative is a polyatomic ion. CH3 positive is a polyatomic ion. Cn negative is a polyatomic ion. But O2 positive, this one is a molecular ion. This one is a molecular ion because when we removed the charge, we found it to be a molecule. It was a stable species, so it is a molecular ion, and the rest of the 3 are the polyatomic ions. So these are 2 important MCQs, and this one is the discussion of the polyatomic ion, the radicals and molecular ions. I hope so that the idea is clear to you people. Thank you so much. See you in the next lecture. Allah Hafiz.